So HTTP is the language of the internet, and we almost always write APIs that compile the entire response and send it to the client. But there is another way of sending the response, and it is called HTTP streaming. In this video, we understand what HTTP streaming is, how to implement it, and how Airbnb uses it to improve its user experience. Now, if you love diving deep into engineering nuances like me, you will absolutely love my courses. All of them take a no-nonsense, no-fluff approach and are aimed at making you a better engineer and helping you accelerate your career. Instead of just scratching the surface, we go in depth into the implementation nuances of all the systems and build quick prototypes to make good design decisions. All the details like curriculum, prerequisite can be found on the respective course pages, and I have linked all of them in the description down below. So do check them out. And now let's resume. So two very common ways of sending responses is one is buffered responses, second one is streaming responses. So buffered response is where in typical case you get a request, your server gets the request, server then goes to database and does whatever processing it wants to do, creates the response. This entire response is created and then is sent to the client. Right? This is a buffered response where your client exactly knows the number of bytes it would receive. Client receives that byte and it does it. On the other hand, there are use cases, for example, LLM applications, where your server does not know how big or how lengthy the response is going to be. For example, in case of LLM applications like ChatGPT, you sent a request. Now server does not know for how long it is going to generate or how long the response is going to be. So what server does, it streams the response to you. Right? Now this streaming is not WebSocket. What we are discussing is HTTP streaming. Right? And this has nothing to do with WebSocket. WebSocket is a separate protocol. Now the whole idea is, the whole premise on which this is built is simple. Your server does not know the length of the response it needs to send, so it sends chunk by chunk. Your client receives the data in chunk and it does the processing. Now, obviously, this looks very fancy, but should we adopt it for all use cases? Not really. If your response is very small, let's say 1 KB, 2 KB, 3 KB, not worth it, right? Not worth the effort that you would require to put in. On the other hand, if your response is large enough or long enough, this will definitely optimize your APIs and optimize your user experience. Okay. Now, what's the whole premise? The whole premise is your server, when server gets a request from the client, server starts processing it. As and when server has some or the other content chunk ready, server keeps sending the chunk to the client. The client, as and when it gets the chunk, it can start processing it. Now, what does it mean that client processes it? It depends on the use case. For example, in some cases, although server does not know the length of the response it needs to send, it keeps sending chunk to the client, and client can choose to accumulate it, which is perfectly fine. Right? On the other hand, there are other use cases like LLM. In this case, your client, as and when it receives the chunk, which means it can start appending to the list or to the interface, and we as a consumer can start reading to it because we are okay processing the partial response that we got from it. Right? So it totally depends on what client does with it. There is no guardrail on, hey, this is exactly what you need to do. It is totally use case specific, but the whole idea is your server does not know how lengthy the response is. The server, as and when it has enough data to send, it sends the data to the client. Client, upon receiving the data, does whatever it wants to do with it. Right? So that's the whole idea. But again, it does not mean you go ahead and adopt it for all use cases. It is better for certain use cases, not so efficient for others. So be very mindful of it, and we'll be discussing the trade-offs in some time. Now, before we go into the Airbnb on how it uses it, let's first understand how to actually implement it. The implementation of this is very simple because it is HTTP streaming is what we're discussing. It by default, or rather it uses a header called transfer encoding chunk. Now, you would have typically seen header called content length. Now this content length header, if you send it in request, you have to send content length header, which tells how lengthy the request body is. If you get the response, in response also content length header is set, which tells how lengthy the response is. Right? Now this content length header signifies that it is a buffered request and buffered response. That's the whole thing. If you do not pass that header, then it is considered as streaming. The core thing is, the whole idea behind this is very simple. The server gets a request. As and when it gets the data, it keeps sending the data with this response header set, chunk transfer or chunk encoding, transfer encoding chunked as a response, as a header that it sends. Right? And this tells client that, hey, I'll tell you when I'm done sending. Until then, whatever I send is the next chunk in the response. Now you do whatever you want to do with it. For example, and although we spoke about protocols, but in reality, the framework that you use, they typically make it relatively easier for you to accept chunked responses or send chunked requests. For example, in case of Express Node.js, this is how your typical code looks like, where you say request on data chunk, where you get that chunk, you do what you want to do with it. In certain case, you may just want to buffer the data because you cannot proceed unless you get the complete response. Although server is sending you in chunks, you have to wait. You might need to wait for your use case, right? That is one. On the other hand, there might be a case where you may just want to display it on the interface. Perfectly fine with that as well, right? In case of Python, which I have very extensively used for streaming responses, in your Flask handler, you simply return a generator and it internally sets all the right headers and it sends the events to it. One of a very good example for this to build is deployment log streaming. Where imagine on a server, a deployment is happening. You write a Python code that reads from the deployment log file and streams chunks to the front end as and when there are changes in the file. Right? Okay. So there are lots of use cases. We'll also go through two of them in the entire discussion. So let's first answer, why do we need to stream? Like, two key advantages that you get from here are, first, it is low and it gives you low and consistent memory usage. This benchmark is taken from Umakant's blog. I'll link it in the description down below, in the iCard down below. The whole idea is you can very clearly see where your memory usage for stream is constant, while if you do buffer, it increases. Now, what actually happened is, because your server, the whole thing is, the sender, whoever the sender is, be it server, be it client, right? Whoever the sender is, your sender is able to send the data that is beyond the sender's memory limit. Because your server, for example, if your server is streaming the response to the client, your server might need to send 1 MB of file. So either server can create a buffered response of 1 MB and then send it, then memory usage shoots up. On the other end, the buffer, as and when it is generated, let's say 1 KB of data, it can keep sending 1 KB, 1 KB, 1 KB, 1 KB to the client. And this way, the overall memory usage does not shoot up on the server side. So on the sender side, that's the key advantage of it. Second is, your receiver can start processing without having to wait for the entire data to arrive. This is again a hypercritical thing, where if you want to craft a great user experience, again LLM example, or LLM and interface being a great example for that, where your server might take 15 seconds to generate an entire response, but your client cannot wait. So what a server will do? Server can stream the text that is generated from LLM to the client, and client can render it. Right? So this is where streaming, HTTP streaming comes into picture. Again, whatever you can do with HTTP streaming, you can also do it with WebSockets, but why unnecessary complexity? HTTP streaming is a really easy way to build a lot of use cases. Okay, now let's go deeper into Airbnb's use cases, or how Airbnb uses it. That's the highlight. Now here you'll see some very beautiful things in action. Right? But before that, let me just take a small detour and show you one code which I wrote back in 2016 to show you how we can do it in Python. And I won't give you a walkthrough of the code. You can easily explore it on GitHub. So I'm switching to my browser. On my GitHub, you'll see a repository called Flask SR. Flask SR stands for Flask Streaming Responses. So I happened to attend a JSFoo conference in 2016, and every single one was showing how they can improve first contentful paint as a statistic, and all of them were doing it with Express and Node.js with React, basically doing server-side rendering of partial chunks and emitting it. And I was very curious, like, why just Node.js? Why just JavaScript? Why not anything else? So which is where you can see my commit are 8 years ago. 2014 and yeah, 2016. Right? So I was always thinking about it that, hey, why are we not doing it in Python? So which is where I built this part. I'll just show you the GIF of it, the impact of it. So if I just zoom in a bit, I hope it. So here you can see the time it takes. So here what I've done, I've just rendered some statistics from my GitHub. By the way, this used to be my GitHub profile photo. But you can see that with Flask streaming response and without Flask streaming response, imagine this is an HTML page that is served from the server. When the server gets the request, your server is compiling the entire HTML using Jinja template and then emitting it back to the client, right? Now here you can see without Flask SR, you can see your entire web page is shown in one shot after 5.5 seconds. But with Flask SR, you can see whatever data is ready, I'm sending it, and that's where your user continuously sees, hey, something is happening. You can see first the nav bar is getting loaded, then the middle section, then the profile photo, and then the right section. Right? The whole thing is very simple. You try to craft a very good user experience over here by not making your user wait for a complete response to be generated on the server side. And again, this is a very simple code, not really difficult, just uses Python coroutines to do it. Give it a read, it's fun. Wrote it 8 years ago. But when I was going through this Airbnb's blog, I thought, hey, I've already done this. And by the way, I took a very similar approach. The blog I'm referring to of Airbnb is of 2023, but this was old back. Like a lot of people have been using it for a very long time, but I found that blog interesting to dissect. So give this repo a read. It's quite fun. If you're a backend developer, you'll still relate. If you're a front-end folk, you'll still relate to it. Okay? But again, I gave you more details for you to implement in whichever language, whichever framework you're comfortable with. Nice. Okay, let's move to the next part. The next part is how Airbnb leverages it. That's the whole essence of it. So what Airbnb does is they just wanted to do this. They just wanted to improve their first contentful paint, which is exactly what we saw in this, where the time at which I send a request and my first thing that is rendered on the UI is the time for first contentful paint. This is one of the key statistics that a lot of company improves on, or they track to see how good the user experience is. Your user typically does not like to wait. Imagine if you're using an LLM application and your ChatGPT takes 15 to 20 seconds to generate a response. You're just staring at the blank screen. But because it was streaming, you are much more engaged with it. Okay, so let's go step by step. First thing is what they do is they do early flush of external resources. Now, what does this mean? This is very simple. The whole idea is what we need to send from your server to client is an HTML response. So what they do is they take this HTML response and they split it into chunks. So one is early flush, and then they stream the second chunk with the other details of it. So what goes in early flush? Early flush is typically your head tag, which contains your JavaScript file, which contains your CSS, which contains any inline scripts that you may have or any meta tags that you have. It takes all of that and streams it when it gets the request, because to generate or to render the other part of the body, it might need to go to database, make a query, and then render the templates and whatnot over there. That might take some time. So which is where they do an early flush of it so that your client or your front end can start processing it because it already got a partial set of response. Okay, this sounds simple, right? But the real question is, how do they implement, right? That's where the thing is, right? If you were to go a step below, like you have to just go a level deeper to understand how they do it, because that's where the magic is happening. So Airbnb is using Express plus Node.js based for their front-end application. They use React for rendering. Now, what they did is they broke this entire page into multiple components, multiple React components, and then they render the React components using the standard render function, render DOM, something on those lines. They use that to render the HTML part from that component. And then they stream it. We saw that res.send. They just keep sending the thing. So res.send, when the chunks are ready, they keep streaming it to the client and client can render it. So what they do is they break it into three parts. So they first write the HTML and head that we saw, right? Then whatever is in the early head, they render it and then the stream. Then they render and write the body, and then the late head. Late head might contain some, let's say, analytics script, mixed panel, amplitude, and whatnot. And then they close the HTML thing, because at the end, your browser needs a genuine valid HTML for it to completely render and be proper with rendering with deterministic experience. Right? So this is what they do. And again, this is very similar to what I did in 2016 after attending JSFooCon. So yeah, totally relatable to that. Right? Okay. The second thing that they need to do is they wanted to minimize the load times. So first we saw is early flush that gives better user experience, because you don't have to, because you can send fonts, CSS and JavaScript beforehand and then worry about your body rendering part of it. The extension to that is you have to minimize the load time. Load time as in, for example, when your browser receives the body tag, what it does is it parses it, right? In the body tag, it might need to, you might have some JavaScript code which goes and makes a call and fetches something, right? The key thing is, what if, now here the waterfall is happening. Let me explain. Let's say my HTML is rendered, right? When my browser is starting to process the HTML that it received, it might encounter a JavaScript code that requires it to make a load call. For example, let's say I'm rendering the profile of a particular person, right? Now for me to render this particular profile of a person, my front end or my back end, either way, needs to make a bunch of API calls to render this and send. Now here it is possible that on my browser, there are some calls that are made from the client side, right, to render that part during initial render. Now the load time, because, and again, you have rendered a primitive interface, now you're going above and beyond. The key thing here is, when this is happening, your browser is parsing through the code, the HTML code. It encountered a JavaScript thing, it made an API call, got the response and then render it. So what is happening is it is rendering. While rendering, it encountered this API call, making an API call, get the response and then render it. Now this shows the loading icon, right? And to craft a good user experience, can we minimize this? So what Airbnb did is they added a new chunk called deferred data. Now what is this deferred data chunk? The deferred data chunk is very simple. The deferred data chunk actually just contains JSON, application slash JSON. It literally contains the JSON response of the API that it would receive. So it sends it. So the whole idea is it sends the early chunk, right? It sends the body with basic layout of it, right? And then it sends the late chunk, which is the JSON part of it. Now the whole idea is that your render is not blocked because you were waiting on that API call. Right? So this is already sent. Your user has seen something on the screen with some, not just loading state, but just maybe a skeleton, maybe loading, maybe default data, whatever, right? Whatever is acceptable for your use case. And then the late chunk is coming. Again, this is also computed from the server side, right? This late chunk or this deferred data that is coming contains the JSON inside it, right? This JSON is then replaced in your state. For example, in React, we maintain a global state. This JSON, once this DOM reaches, using mutation observer. So mutation observer is basically, you can create mutation. This is exactly what I also use in my Flask SR repository. What it does is you can listen to changes on a particular DOM element. And whenever something changes, you get a callback. And then you can do whatever you want to do with it. So if you say that, hey, when this comes, it would take that, parse the JSON and populate it in the state. So this way what happens is your state is hydrated. It got the response and your actual state is hydrated. Right? So that's how you essentially minimize your load times. Right? So in one shot, you are not, again, the core highlight, if you observe, is you have already sent something which is initially getting rendered, and then you are replacing it with the JSON that you received, directly replacing it in state rather than waiting for one more API call to go from front end to back end, and then back end it would compute and send and whatnot. So it again further minimizes the load time. Right? These are two very interesting things that Airbnb did that I wanted to talk about. More importantly, let's talk about one interesting implementation challenge. This is what I also face. So which is I love to cover this. Is we typically take things for granted. Hey, this is the optimizations and this is what it did. But when you ship to production, there are lots of nuances that you need to cover. One of them that I would want to highlight is if you have a front-end proxy, reverse proxy like an Nginx or what, so they might buffer the responses. So it is very much possible that and by default Nginx does buffering, which means even though your sender is sending in chunk, if you have Nginx sitting in between, it would buffer. Once the response is done, then it would send. Right? So what you need to do when you're shipping into production, remember switching off the buffered thing in production for at least for that request. For other request, you might select that, but at least for that request, disable the buffering so that you can get proper streaming of responses. Right? And yeah, this is all what I wanted to cover. All the relevant links to the things that I referred to, my repository, Airbnb's blog, Umakant's blog, all of them are linked in the icon, which you can find above the video first. Second, you may also find below the description of it, right? And whatever we discussed, try to prototype. It's beautiful concept, and backend folks, frontend folks, it's not a war. At that, it's pure engineering. And if you can build a quick prototype, it's quite fun, and it would help you build up much better understanding. And in general, be curious about anything and everything under the hood, because engineering is beautiful. But again, spend some time doing it. You'll have a great time. Plus, especially when you start seeing the response. The demo I gave, the demo I showed about Flask SR. If you try to mimic something similar, it will be quite fun when you do that. Right? So yeah, this is all what I wanted to cover in this one. I hope you found it interesting. Hope you found it amazing. That's it for this one. I'll see you in the next one. Thanks a ton.